Welcome to the DIY Honda Garage channel. The DTC P15C9 indicates a problem with the brake booster pressure sensor A. This sensor monitors the vacuum pressure in the brake booster, a critical component that assists the driver in applying the brakes. The brake booster itself is typically located near the master cylinder on the driver's side of the engine bay. A malfunction in this sensor can result in inefficient brake performance, posing safety hazards while driving. It is important to address this issue promptly, as it could affect the vehicle's braking system. Before proceeding with specific troubleshooting, any related PGM-FI powertrain gasoline multi-point fuel injection, DTCs, must be checked and resolved. Understanding the implications of this DTC will aid in the correct diagnosis and repair of the issue. The DTC P15C9 highlights a locked output voltage condition from the brake booster pressure sensor, A. This sensor is vital for monitoring vacuum pressure levels, which directly affect braking efficiency. Positioned near the master cylinder, the brake booster is instrumental in enhancing the driver's braking force. The output from this sensor informs the powertrain control module, PCM, about the brake system's current state. If the voltage output is locked, it suggests that the sensor may be malfunctioning or that there's an underlying issue, such as poor wiring or electrical connections. Correctly diagnosing the sensor's functionality is critical to ensure the vehicle's braking system operates safely. Several potential causes may lead to the DTC P15C9. First, a malfunction in the brake booster pressure sensor itself is a likely culprit. Sensors can fail due to wear over time or external factors like exposure to heat. Poor electrical connections are another common cause. Loose or corroded terminals can hinder proper voltage transmission, leading to erroneous readings. Additionally, issues within the vacuum lines, such as blockages or leaks, could contribute to a false output from the sensor. Identifying these potential issues is essential before proceeding with repairs to ensure a complete resolution of the DTC. Drivers may experience several symptoms related to DTC P15C9. A noticeable decline in braking performance can occur, making it more difficult to stop the vehicle safely. You may also notice an inconsistent feel in the brake pedal, which can vary in pressure and effectiveness. A dashboard warning light may illuminate, alerting the driver to potential brake system issues. If these symptoms arise, they could indicate that the brake booster pressure sensor is not functioning correctly. Attention to these warning signs is crucial, as delayed action can lead to dangerous driving conditions and further damage to the vehicle. The first troubleshooting step in addressing DTC P15C9 is to switch the vehicle to the on mode, which powers the vehicle's electrical systems without starting the engine. Once in this mode, it is essential to check for any pending or confirmed DTCs within the powertrain gasoline multi-point fuel injection system using the HDS Honda Diagnostic System tool. This step is crucial because it ensures that any existing faults are identified before specifically addressing the brake booster pressure sensor. If any DTCs are present related to the PGM-FI system, you must proceed to their respective troubleshooting paths. If there are no outstanding DTCs in this system, you can move on to the next verification step. For the second troubleshooting step, start by turning the vehicle to the off or lock mode. This initialization is necessary to reset the system properly. Following this, it is important to press the brake pedal several times. This action helps deplete any residual vacuum in the brake booster system, preparing it for an accurate diagnosis. After completing these steps, turn the vehicle back to on mode and use the HDS to check the values of the brake booster pressure sensor A while the engine is started. The HDS will provide real-time data on the sensor's output. If the value changes appropriately when the brake is pressed, it suggests that there is intermittent failure, and potential electrical connections should be inspected further. If no change occurs, it indicates a more significant issue with the sensor itself. In the third troubleshooting step, once again turn the vehicle to the off or lock mode to eliminate any pressure in the system. After ensuring the system is off, press the brake pedal several times to fully deplete the vacuum. This step is essential in establishing a baseline condition for testing. Next, while pressing and holding the brake pedal, start the engine. You must check if the brake pedal sinks during this process. If it does sink, it indicates a possible failure in the brake booster pressure sensor and necessitates its replacement. On the other hand, if the pedal does not sink, this may suggest a blockage in the vacuum line or related components, requiring further inspection and potential repair or replacement of any obstructed parts. After completing the necessary repairs for DTC P15C9, it is crucial to verify that all work has been effective. Start with confirming that the brake booster pressure sensor was properly replaced or repaired, depending on the scenario. Following this, test the vehicle's brake performance to ensure that the braking system is functioning correctly and safely. A road test should ascertain that the brake pedal has the correct feel and response. Finally, use the HDS to rescan the systems for any remaining or new DTCs. This final scanning helps verify that the issue has been resolved and ensures that no additional faults are present in the vehicle's systems. To prevent issues like DTC P15C9 from arising in the future, regular maintenance is paramount. Schedule periodic inspections of the brake system, focusing particularly on the brake booster and its associated pressure sensor. Keeping vacuum lines intact is important. Inspect them for signs of wear or damage regularly. Ensuring that all electrical connections related to the brake system remain clean and secure will help avoid issues stemming from poor connectivity. Using high-quality components during repairs can also reduce the likelihood of premature failures. By incorporating these preventive measures, vehicle owners can enhance the reliability and safety of the braking system. In summary, the DTC P15C9 is a crucial diagnostic indicator that highlights potential issues within the brake booster pressure sensor and its effectiveness. Understanding this code helps owners take necessary actions for repairs to ensure their safety. Efficient braking is not only essential for smooth driving, but critical for vehicle safety. Overlooking warning signs can lead to dangerous situations on the road. Timely and correct diagnosis through the specified troubleshooting steps is vital to resolving the issue accurately. Adopting preventive maintenance practices can significantly reduce the risk of similar problems occurring in the future. Keeping a close eye on brake performance and being proactive can ensure optimal safety and functionality in your Honda Pilot. Please like and subscribe to the channel. See you next time.